For our AB Calculus video tutorial project, we are doing problem number 6 from the 2010 AP non-calculator response portion. The problem gives us the first derivative equation, the second derivative equation, and a point. These key points will help us solve problem A, B, and C. Question A asks us to write an equation for the line tangent to the graph of y equals f of x at x equals 1. In order to find the equation, we have to use the given point 1, 2 and the first differential equation dy over dx equals xy cubed. First, we have to find the slope of the line at x equals 1. So we plug in the point 1, 2 into the first differential equation. A differential equation gives you the slope of a tangent line to a graph at a certain point. So now you get dy over dx equals 1 times 2 cubed equals 8. Therefore, the slope at x equals 1 is 8. To find the equation, we plug in the slope and points into the point-slope equation, which is y minus y1 equals m times x minus x1. After plugging in, we get y minus 2 equals 8 times x minus 1. Question B asks us to use the tangent line from part A to approximate f of 1.1. To do this, we have to plug in 1.1 for x into the equation y minus 2 equals 8 times x minus 1. First, you get y minus 2 equals 8 times 1.1 minus 1, which equals y minus 2 equals 8 times 0.1.
Nova Games use 3 bonds. You have the rules?
Which equals y minus 2 equals 0.8. Which equals y equals 2.8. This is approximation for f of 1.1. The second part of part B asks us to explain whether or not the approximation for f of 1.1 is greater than or less than f of 1.1. With the given information, f of x is greater than 0 when x is greater than 1 and less than 1.1. Because f of x or y as well as x are always greater than 0, when we plug in these values into the first and second differential equation, we always get a positive number. This means that f of x is increasing concave up when x is greater than 1 and less than 1.1. An increasing concave up graph will always lie above its tangent line, so that the tangent line approximation is less than its actual value. For part C, we are asked to find the particular solution y equals f of x with the initial condition of f of 1 equals 2. To find the equation of f of x, we have to find the antiderivative of dy over dx equals xy cubed. First, you multiply both sides by dx and 1 over y cubed to get dy over y cubed equals x dx. Then you take the antiderivative of both sides. And don't forget plus c. To solve for c, plug in the point 1, 2 to the equation. C comes out to be negative 5 over 8. Plug c back into the equation and solve for y or f of x. Multiply both sides by negative 2. Inverse both sides. Take the square root of both sides. The final answer is square root of 1 over negative x squared plus 5 over 4. The positive square root was used since f of 1 equals 2, which is greater than 0.